Hey everyone, welcome. So today's explainer is going to be a lot of fun and, maybe a little humbling to be honest. We're going to look at 5 real-world SQL queries that an AI can actually write better than most humans.
All right, let's just get right into it. The big question here isn't just, can AI write SQL that's decent, or is it as good as a junior analyst? No, we're asking something bigger. Can it be demonstrably better? Like cleaner, faster, more optimized, and in some cases, even a little more creative.
And what we found for some really common tasks that data analysts and engineers do every single day is that the answer is a huge yes. It's kind of shocking, really. So for each of the 5 examples we're about to walk through, I'm going to show you the typical human approach and then the AI's version. And we'll break down exactly why the AI solution is so darn good.
Okay, let's kick things off with our first challenge. This is a classic, right? It's all about handling some complex joins and aggregations. This is the bread and butter for anyone working with data.
So here's the business question, and it's super straightforward. We need to find the total revenue, and here's the key, only from our best customers, the ones who've made more than 3 purchases. Seems simple enough, doesn't it?
So this is where it gets really interesting. Look at the difference in how this is structured. On the left, you've got the typical human approach. We use a group by and then a having clause to filter our groups. And look, it's technically correct. It gets the job done. But then, look at the AI's version on the right. It uses something called a common table expression, or a CTE. Now just think of a CTE as like a temporary named table that you build on the fly. The AI creates this little temporary table called customer stats, does all the heavy lifting in there, counting orders, summing up revenue, and then in the final step, it just selects from that nice, clean, prepackaged table. It's just a much more organized way of thinking.
So why does the AI's version win? Well, first off, it is way more readable. The logic is broken down into clear steps. First, we calculate the stats, then we filter. This separation makes it incredibly scalable. If you need to add more complex logic later on, you just build on top of that CTE. It's so clean. It really shows how the AI just defaults to using CTEs, which is absolutely a best practice for writing professional, production-ready SQL.
All right, let's move on to query number 2 and see how this whole thing builds. Here, we're going to look at a task that often involves calculating proportions, figuring out a piece of the whole pie. And this is something that can get really messy really fast.
And the task is another one of those daily drivers for analytics teams. We need to figure out what percentage of our total company revenue comes from each individual product. Super common request. Now, the typical human approach, on the left, often involves sticking a subquery right inside the select statement to go find the grand total revenue. Again, it works, but it's so clunky and it's inefficient because the database has to rerun that little subquery for every single row in your table. The AI, though, it uses something far more elegant, a window function. A window function like sum over over is amazing. It performs a calculation across a whole set of rows at once. So in this case, it calculates the grand total just one time, and then it kind of stamps that value onto every row. It's so much cleaner and way, way faster. The bottom line here is that the AI's version is just vastly more efficient. It completely avoids that performance hit you get from a subquery, the logic is way cleaner, and it's much easier to build on later. It really seems like these AIs have a natural talent for window functions, and what's more important is they use them correctly right out of the box. It's a game changer.
Okay, so for this next part, we're actually going to bundle 2 queries together, and that's because they both test something that often trips up humans: tricky conditional rules and, well, logical puzzles.
So first up, a classic segmentation task. We just need to put our customers into different buckets based on how much they've spent: high, medium, and low. Simple, right?
Now, we humans solve this with a case statement, which is totally the right tool for the job. But let's be honest, we often write them with messy indentation, or we get the order of the conditions wrong. The AI's version, though, it's a masterclass in clarity. Even though we're not looking at the code side by side, just picture it. Perfectly indented, conditions ordered logically from highest to lowest. It's just simple, elegant, and totally flawless.
And now for the trick question. This is one of those logic puzzles that can trip up even seasoned analysts. We need to find customers who placed an order in January, but then placed 0 orders in February.
A super common human mistake, which you can see on the left, is to write something like where month equals 1 and month not equal to 2. But that logic is just broken, right? No single row can be in both month 1 and not month 2 at the same time. The AI, on the other hand, wow.
It produces this amazingly clean and scalable solution. It uses a CTE and something called conditional aggregation to create little flags for each month. It counts up the January orders and the February orders for each customer, and then it just filters for the people where January orders are more than 0 and February orders equal 0. It is just brilliant.
And that brings us to our final query. And honestly, this one is the most impressive of all. This is a complex, multi-step problem that requires the kind of structure you'd expect to see from a senior data engineer.
Okay, let's break this task down. We need to find the average order value for each employee. Simple enough, but here's the twist. We only want to include sales from our most active customers, the ones who've placed 5 or more orders. This is going to require multiple joins, filters, and aggregations all working together.
Now, before we even peek at the code, let's just look at the AI's plan. This is what's so cool. It breaks the whole problem down into these logical, bite-sized steps. First, it's going to count the orders for every customer. Then second, it'll create a list of just the valid customers who meet our criteria. Third, it calculates the sales data. And then finally, it puts it all together to get the final averages. This is exactly how an expert human would map out their attack plan.
And this right here perfectly illustrates the result. The AI spits out this beautiful query with multiple CTEs that are all chained together. You can kind of see the structure on the screen. Each step is named logically, like customer order stats or valid customers. This makes the entire query basically self-documenting. It's perfectly readable, it's high performance, and it is structured exactly like something a senior data pro would architect. It's genuinely impressive stuff.
So what's the big takeaway from all this? Is AI coming for our jobs? Is it here to replace SQL analysts? Not at all. The story here is really shifting away from replacement and towards collaboration.
The best way to think about it is that AI is your new teammate. It's the best SQL assistant you've ever had. As you've just seen, it consistently writes cleaner SQL, faster SQL, and way more maintainable code. When you start using AI as your collaborator, you're going to work faster, you're going to learn best practices just by watching what it does, and ultimately, you're just going to become a better, more effective data professional.
At the end of the day, this isn't really about who's better, human or machine. It's about what becomes possible when you pair human creativity and business sense with the AI's incredible speed and precision. Your AI assistant is ready to go. So the only real question left is, what are you going to build together?